Okay, so today we are going to be talking about quadratic equations for the first time. I think we've referred to the word quadratic with regard to degree on occasion, but this is the first time we're really going to be learning about some quadratic equations, what it means to solve one, what does a graph of one look like. Does anybody know what a quadratic equation is? So a quadratic equation is an equation that has a degree of 2. If you remember what degree means, that means the exponent on any of the variables there can be no bigger than, it's got to be 2, right? So the greatest exponent, and it has to have an exponent of 2 to be a quadratic equation. So you learned earlier in the year we reviewed and learned again about solving linear equations. When you graph a linear equation, you get a line. When you graph a quadratic equation, you don't get a line. It's a different looking graph. So an example of a quadratic equation is this one. X squared plus 6x plus 9 equals 0. So this is a quadratic equation because the degree of this equation is 2. That means the greatest exponent in there, in each term, is has a degree of 2. If it doesn't have an exponent with a degree of 2, it would not be a quadratic equation. Mrs. Zimmerman. Hey. Yes? No, they can come get it. Okay. All right, great. Thanks so much. I'll send her over. Thanks, bye. Hey, security, will you walk over to Nettles building and pick up something from 13 from me? Second floor, room 209. Grab our tax right there, okay? All right, so quadratic equations can have one solution, 2 solutions, or no solution. The next part you don't have to write, I just want to talk to you about it a little bit. Actually, I think I like it better on the, no, maybe I'll put it here and put it in the video. It's going to be on the whiteboard, but I'll do it here. All right, so I mentioned the linear equation. The graph of a linear equation is a line. The graph of a quadratic equation is something we call a parabola. So these are examples of the graph of 3 different quadratic equations. Okay? Let's actually switch this one. I told you that quadratic equations could have one solution, no solution, or 2 solutions. So the parabola can open up or it can open down. It doesn't matter. It can't open left or right or would not be a quadratic equation. So these are examples of the graph of a quadratic equation. These are also examples of 1 solution, 2 solutions, or no solutions. Anybody have an idea which is which? Which would be 1 solution? Which would be 2 solutions? Which would be no solution? Looking at the graph. You think you can figure it out? Dan? Okay. He says the first one is 1 solution, the second one is 2 solutions, and the third one is none, and I will say he's right. What made you think that, Zion? Mm. Mhm. Mhm. Okay, so you're right. One solution, two solutions, two solutions, and the third one is no solution. Reasoning is not exactly right, but it's okay. It was a guess. That's all I asked you to do. Anybody else see a reason why that might be true? Why might the first parabola represent one solution, the second two, and the third none? Kara? I will tell you, if Kara's getting warmer. Okay, so she's much warmer. So she said, because it's touching, where it touches the x and y axis. Really, we don't care about the y-axis. What we're looking at is the x-axis. This one, neither ugly parabolas because it's hard to draw them on here. This one touches the x-axis in one point. Okay? This one touches the x-axis, and we're going to pretend it's touching here, in 2 points. This one doesn't touch the x-axis. So the solution to a quadratic equation depends on where it touches or if it touches or intersects the x-axis. So here, this ordered pair would be, this is not a great example. You're not copying it, so I'm going to erase it and give you a better example of that one. It's not supposed to be a V. A V is wrong. A V is a different thing. So use your imagination, pretend it's a parabola. It's rounder than that, okay? If it touches, and we're also going to suspend reality and say it touches right there. If it touches right there, 1, 2, 3, 4, that ordered pair is 4, 0. Make sense? If it touches here, we're going to say this is negative 4, 0, right? Because we're pretending it goes through there. Here, I'll modify it. This one is, 3, 0. And this one never crosses. Make sense? So I will tell you that the solution for this parabola is 4. The solution for this parabola is negative 4 and positive 3. And this one is no solution. Okay? So the solution to a quadratic equation is the x value. What do we notice about all the y values in those ordered pairs? They're all what? They're all 0, right? So when y is 0, if we solve for x, then that is the solution to our quadratic equation. Right? So right now we're going to solve by factoring. There's lots of ways to solve a quadratic equation. There's a couple ways that work every time. Factoring does not work every time, but all of our examples are going to work that way. All right, so there's different things we can call solutions. There are also sometimes you might see them referred to as roots. On the EOC, it's important. If they ask you to find the root of the equation, you have to know that that just means find the solution. All right, and the other one is 0. And I could be wrong, but I think they're called zeros because that y coordinate is always 0, right? When the solution is the x when y is 0, right? So we're going to call them zeros just for today. We practice calling them all different things because you may see that terminology differently. So we're going to call them zeros because it might help us remember how to solve them. The steps to solve a quadratic equation are going to involve us setting the equation equal to 0 and then setting factors equal to 0. So 0 is very important in this lesson. So today we are solving quadratic equations by factoring. It's important to remember that not all quadratic equations can be solved by factoring, but the ones we're going to see today can be, right? If the expression is not factorable, that does not mean it can't be solved. It means we can't solve it by factoring, okay? So there's basically 3 steps to solving a quadratic equation by factoring. In fact, you could solve lots of different kinds of equations by factoring, but today we're only working with quadratic ones. So to solve by factoring, the first thing you're going to do is set the equation equal to 0. Our example quadratic equation is the front top of our notes. That equation is set equal to 0. All that means is there's something on the left side and it's set and it's equal 0. So one of the sides has to be 0. Everything else has to be on the other side of 0. Make sense? Okay, that's all it means. Now, they won't always be set equal to 0 already. We might have to rearrange the terms to get it equal to 0. Once it's equal to 0, though, then we can factor the side that's not 0. So factor that polynomial expression. In our case, usually it's going to be a trinomial for these. So once you factor it, then you're going to have at least 2 factors. And you set, well, you might have 1 factor because there could be 1 solution. Once you have the factors, you set each factor equal to 0. So that means you take the factor and simply write equals 0. So we're going to do one example. You're going to have to switch the example because I didn't like the original example that I put, so I switched it for this period. I'm going to have to rewrite the example at the bottom of the page. Okay, ready? So this one, we're going to switch it to x squared plus 10x equals negative 21. You can just scratch that whole thing if you want and write this one to the right. X squared plus 10x equals negative 21. You can see that this is a quadratic equation because it has a term with an exponent of 2 on the variable. Now, just like all other equations, you don't have to use the letter x for a variable. You could use other variables, right? But we call that squared term, we call that the quadratic term, right? So that's what makes it a quadratic equation. And the fact that it has an equal sign, remember, it can't be an equation if it doesn't have an equal sign in it. All right, so our first step said we need to set this equation equal to 0. All right, so we need equal 0 on the right side. Since this is 1 term, there's 2 terms over here, we are going to get this equal to 0. What do I have to do to negative 21 to make it 0? We could times it by 0, right? But whenever you do one side, we have to do the other side. So we multiply this by 0, and we multiply all this by 0, then our whole equation goes away. So we don't want to do that one. So let's add something to negative 21 to make it 21. Add 21, James said. James, remember, you can add the opposite of any number to itself. So 3, the opposite is negative 3. 3 plus negative 3 is 0, right? The opposite of negative 4 is positive 4. So the same numbers, just opposite signs, right? Negative 4 plus positive 4 is 0. So negative 21 plus positive 21 is 0. So that's what we need over here. So we're going to add 21. So we're going to go over here. Whatever you do to one side of an equation, you have to keep that equation balanced, right? You can't change the value of the equation. So we're going to add 21 to both sides. That leaves me x squared plus 10x plus 21 equals 0. So that's our first step done. The second step says we're going to factor the part that's not 0. So we're going to factor x squared plus 10x plus 21. You just finished this it's factorable, but we would, when we're checking it, it's not factor. If we can't find factors that equal our constant, then it wouldn't be factorable. But all of yours are going to be factorable today. Lee says it's 7 and 3, he's right. But let's go ahead and go through our little strategy. He's exactly right. The factors that equal. So we're looking for the factors that equal our product of 21 to the sum of positive 10. So 7 times 3 equals 21, and 7 plus 3 equals 10. That means that our factors is going to be plus 7 plus 3. What's going to go in the first spot? Not x squared. X, right. So the square root of this always goes in the first spot. And if there's not a number in front here, this is all we have to do. So we've set our equation equal to 0, and now we factor the part that's not 0. What's the last step say to do? What's the last step say to do? Set each factor equal to 0. So one factor is x plus 7, the other one is x plus 3. All we're going to do is write equals 0 equals 0. So now we have these two simple equations, one-step equation. Sometimes you're going to have a two-step equation, but that's as complicated as it gets. One or two-step equations here. Doesn't get complicated for this part. So now if we solve x plus 7 equals 0, we subtract 7, and x equals negative 7. For here, we want x by itself, we're going to do the opposite of adding 3, subtract 3 from both sides, and x equals negative 3. So these are our solutions. The solution of this quadratic equation is negative 7, negative 3. We typically don't leave it in this form. We write it in step notation, so that's these little squigglies. If this quadratic equation were graphed, it would look something like this. Something like that. That's a very rough version, but it crosses at negative 3 and negative 7, right? So that is the solution to that equation. That's somewhat what it would look like. Definitely this part is what it would look like. It would be a parabola. It would be opening up like that. Okay? Any questions? Okay. Well, let's look at your first question on your homework and do that one together. Get a few minutes, we can do some of your homework together. So the first, these numbers are weird because they were pulled from different worksheets. You know how to factor all these, or we've practiced factoring all these terms. So we're going to start with number 20, the first number 20, which is b times b plus 12 equals 0. The beauty of this example is most of it's done for us. Right? Is this equation set equal to 0? Yep. The next step is a factor, but isn't this quadratic equation factored already? Yeah, we know it's quadratic. B times b is b squared, right? So now all we have to do is the third step. So if it's already factored, it's super easy. So what we do is we take our factors, b and b plus 12, and set them equal to 0. We're going to write our solution in our set squigglies. So if there's two factors, unless they're identical factors, which they could be, if they're the same factor, then you only have one solution. So we already know that b is 0. There's nothing to solve there, so that's going to go in our set. And now we're going to solve this one-step equation. To get b by itself, we have to subtract 12 from both sides. And now we know that b is negative 12. So your homework says to check these. I'm not going to make you check any of them except the one we're doing together. You can check them to see if your solutions are correct, right? How do we do that? So we're going to check just this one. So what we would do is we'd take 0 and negative 12 and we plug it into this equation. You have to do it 2 different times, right? So for the first one, we're going to plug in 0. So instead of b, we're going to say 0 times 0 plus 12 equals 0. So we replace the b with 0 in both spots. Make sense? All right, so this would be 0 times 12. And the question is this equation a true statement? Well, what is 0 times any number? 0, right? So 0 times 12 is 0. So we know that 0 is one solution of this quadratic equation. Now we're going to take our other solution, negative 12, and plug it in. So everywhere there's a b, we're plugging in negative 12. So there was a b here and a b here, and now we have substituted that with our other solution. So order of operations, always do what's inside those parentheses first. So we have negative 12 times, what's negative 12 plus positive 12? 0. So negative 12 times 0 is 0. So our answers, if you plug them back into the equation, should always make the equation equal to 0, right? Any questions? All right, let's do a question from the next section. First period wanted me to do 24 with y'all. You want to do 24 together, or do you have a different one you want to do? Anybody? 24 good? 24 good. So the second section, so I'll do the 24 from the second section, and that is a squared plus 14a. Thank you. Equals negative 45. And you can do this one on your homework paper. You don't have to do it in your notes. So what's the first thing we should do here? Anson, any idea? We have 3 steps. Say it again. Set it equal to 0. Good. It's not equal to 0 now, so how am I going to get it equal to 0? So then, plus 45 on both sides. And plus 45 here because that makes this side of the equation equal to 0. But we have to do everything to both sides. So a squared plus 14a plus 45 equals 0. So this form of a polynomial that we're going to factor, now the next step is to factor, right? There's not a number in front of this, so we're going to factor just like we factored the last one. Give ourselves an x. We're looking for a product of what? 45. I need to add to what, Anson? 14, very good. So what factors of 45, when you add them together, will equal 14? 9 and 5 is exactly right. So 9 times 5 equals 45, and 9 plus 5 equals 14. So now we learned that when you factor this form of a trinomial, it factors into 2 factors. Now, if from the greatest common factor, we would have pulled that out first, just like we did the whole last chapter, whole last unit, okay? So now we know what's going to go in the first spot here. What times what equals a squared? Yep, a times a. And these are both positive, so plus 9 and plus 5. A plus 9 times a plus 5 equals a squared plus 14a plus 45 equals 0. It also equals a squared plus 14a equals negative 45. So it's the same thing. Okay? So now what's our last step? Print your earpods up 16, but get both earpods in. No music on that? No. Good. Okay. So what are we going to do with those factors? What are we going to do with our factors? Can you see, you know? And what do we do with these factors? do we do here? We have x plus 7 and x plus 3. What do we do with those? No? Jeremiah, any idea? What do we do with our factors now that we have them? 7 to 0, that's right. So a plus 9, what does it mean to 7 to 0, Jeremiah? Just write equal 0, buddy. All right, so sometimes it seems too easy, right? Sometimes it is really easy. That's a 9. It looks like an A there. A plus 9 plus A plus 5. So now we solve this equation, subtract 9 from both sides, and now we know that A can equal negative 9. To get A by itself for this equation, we subtract 5 from both sides. So our solution set, we're going to make our squigglies and put both of these in here. Negative 9, negative 5. Any questions? And I think we did number 24 in the bottom one as well. So if you want to do, you guys want to do 24 together? The last section. It doesn't look like any of the others that we've done. Y'all caught up with me? Okay. So our next 24 is 6d squared plus 21d equals 10d plus 35. So if we follow our steps here, how is this one different than the ones we've been doing? Xavier, how's this one different? Do you notice? How's this one different? No? What do you think, Fatima? How is this one different than the other problems we've done? Okay. Diane, what do you think? 4 numbers, right? So between what Diane said and Fatima said, I know that they both have noticed. So some of our equations were already set equal to 0. Some of our equations had only one number on the other side and no variable, right? This one has 2 on each side. We need them all together, so which one do we move, right? I like to work my equations with the 0 on the right side, but really the important thing is here, we don't want to move the quadratic term. We don't want to move the 6d squared because we want that one to stay positive. If that were negative, we'd move it, so it'd be positive. Does that make sense? So what we want to do then is we want the right side equal to 0, so we're going to move these one at a time. It doesn't matter which one we move first. Which one do you want to move first, Annabelle? 35. Okay, so we're going to subtract 35 from both sides, because that's how we get that to 0, right? 35 minus 35 is 0. So now what we have is 6d squared plus 21d minus 35 equals 10d. So now, how do I get rid of the 10d? How do I move the 10d? I need to move that one as well, right? So that's the thing, we've never had to move 2 terms. So how do I make the right side equal to 0 if I have 10d there? Subtract 10d, very good. Subtract 10d, not just a 10, but 10d. Now, 10d can't be subtracted from this term. It can't be subtracted from the constant. It gets subtracted from the other d term. So we have 6d squared left. 21d minus 10d is 11d. Minus 35 equals 0. So this one isn't our favorite one because it's already taken more work than the others, right? Now, this form is not our easy form to factor either. So this form is ax squared plus bx plus c. So how do we factor remember? You have a 6 in front, what do you have to do? You have to rewrite this as 4 terms, and then you factor by grouping, right? So we need to split our middle term into 2 terms. So we need our x, and now we're going to do AC, where 6 is A, and negative 35 is C. And now check me that I think it's negative 210, is that right? Somebody multiply that for me? Is that right, David? Okay, great, thank you. So my product is negative 210. What does my sum need to be? What's the sum need to be? Kendall? 11, very good. So the factors of 21, that it negative 210, add them together will be 11. I don't know many factors of 210, but I do see that a 10 will come out of it. And as luck would have it, 21 divided by 10, 210 divided by 21 is 21. All right, I said it wrong both times. Negative 210 divided by 10 is 21. Y'all got me? Naughty. We do know that one needs to be positive and one needs to be negative. Which one should be positive and which one should be negative? So I'll have a positive 11. Diane? Negative 10, positive 21. That's exactly right. Negative 10 to positive 21 is negative 210. Negative 10 plus positive 21 is positive 11. So now we're rewriting. First and last terms stay the same, and we split the middle term. Minus 10d plus 21d. Now we factor by grouping. This is stuff we've done, so I'm going to go ahead and do this because I think we're running out of time. Oh, this is also equal to 0. So we're factoring this part. So now, we know we're going to have 2 binomials. We're going to take the greatest common factor of these two. That's 2d. The greatest common factor of these two, that's a positive 7. We divide these first group by the first greatest common factor, just like we did the last unit. 6 divided by 2 is 3. D squared divided by D is C. Minus, because that's a minus. 10 divided by 2 is 5. And D divided by D is 1. So those are our factors. And now we set the factors equal to 0. What is that? Tell me what to write for my first one. Naya, what do I write? What are the 2 factors, Naya? I do. 2d plus 7 is my first factor. How do I set that equal to 0, Naya? Just write equals 0, that's right. What's the other factor? What's the other factor to Corey? So 2d plus 7 is one factor. What's the other factor? What's the other factor, Ulrich?
3d minus 5 is 0.
The other factor is 3d minus 5, and to set that equal 0, we just write equals 0. So now we solve these equations. If there's 2 steps, and there are 2 steps here, we're going to undo the adding first. Now we have 2d equals negative 7. Divide both sides by 2 to undo the multiplying by d. And our first solution is negative 7, 2. So our negative 7 halves. And now we're going to add 5 to both sides. 3d equals 5. Divide both sides by 3. to solve that one step equation we have left, and D is also 5/3. So those are the two solutions. The solutions can be written as fractions or decimals. Any questions? Don't forget to submit your notes, and finish the problems that we didn't do. Tomorrow we'll do a second day on this. We're also having a test on next Friday, a very short unit.